Hello. Let's come to next episode 12 of geopolitical, economic, technological, social environment. In this session, we will take care of the technological environment. First, look at very wide canvas, then come to after independence 1947, then come to, let us say, 21st century, and the latest we have now. Obviously, technology is global, has been for quite some time. Paper invented in China, imported into India and Europe, nitrate, use of dynamite from one place to the other, and so on. So technology is really not local, and if it is good, it travels, it diffuses. Even country of the size of pre-independent India is quite wide, and there also irrigation practices, kind of tractors, kind of mechanization, warehouses for storing grains, etc. The technologies were somewhat different from, let's say, broadly, what North is and what South is. So, going back, Indus Valley civilization and the Chinese civilization had developed quite a bit of technology for use in agriculture. These societies were basically agricultural. And for the military equipment, because Ireland started using the wheels very effectively and also made special steels for swords, special woods for bow and arrows, and therefore, globally speaking, they were on the frontier edge, so were China. Their arts using technology, paper mache in India, in Kashmir, then things related to jade, etc. in China. Silk, very important, because when the trading starts between Europe and China, then they import silks from there, produce opium in India, and feed them opium. And that is what had led to the opium wars in China and England. And to that extent, China got became quasi-colony. So it was related to technology again. Europeans by 14th, 15th century had started mastering fire weapons, and in many parts of Asia and Africa, this technology had not yet been developed of various kinds of fire weapons, and also then started extending themselves with the shipping so that they could go large distances, etc. Now, more of that part I do not go at this stage because it's longish, but the technology between 15th century to 19th century, Europe had taken a lead, and then slowly, once the decolonization started, big civilizations like China and India, and then also ASEAN countries, but hardly any African countries, because African countries got their independence in 1960s, and effectively, even now they don't have the independence. USA, after World War I, because it became a supplier of the weapons, became kind of leader. By World War II, it made lots of advances in steels, in fire weapons, in atomic bomb, and related ammunitions. And by the time the World War II got over, the other parties were weakened. That means the Western Europe countries, Germany, France, Italy, etc., and also Soviet Union was weakened. So in the weapons technology and related technologies, use of electronics, the US became the leader. Now, how does the technology diffuse from there? Because they were so dominant, after that, the diffusion takes place through companies. In other words, the capitalism starts becoming stronger and stronger and stronger, and finally defeats communism or socialism when 1991 the Soviet Union breaks up. Now, during this era, there was competition between USA and USSR, and interestingly, on one aspect where a lot of new developments took place, and we will spend some more time on it today, and that is related to space. USSR also went ahead in terms of the atomic bombs. In fact, made more than USA. Missile technology therefore got developed. Rockets got therefore developed. And with that, going to the space. First flight to carry human beings, Yuri Gagarin, USSR. First flight to carry a human being to moon, USA. Now, with this technology improving, of course, they didn't have sufficient engineers, and believe it or not, NASA has a majority of Indian engineers. Now, this is where people started going for studies to USA, UK, Europe, etc. from India. Now, in parallel, the policy of the government, 56 onwards, Jawaharlal Nehru, Prime Minister, he was a great believer in science and technology. He used to call the labs which were set up, CSIR lab, DRDO, or also the dams, as temples of democracy. Temples of advancement were the research labs. Now, these were all government funded. Under the central CSIR, there were labs on chemistry, chemical engineering in Pune, and there were labs on aeronautics in Bangalore. There were labs, other labs there in Bangalore. Indian Institute of Science was supported a lot, and therefore a conglomeration developed there, just like it had developed in near around Stanford University in California, and then around MIT in the eastern area. And of course, I can keep on counting one center each in Europe, but mostly they were the capitals in Europe. Now, these laboratories had very competent people, but there was no connect to the market. Even though they filed patents, and earlier they didn't bother even much to file patents, they did not get converted into production because the businessmen were not interested in taking any risk. They were risk averse, and their openings in trading, their openings in setting up cement plants, steel plants, carbon black, textile mills, something which they could see will sell. However, to develop technology into products is a longer task, a more risk-taking task. There were some groups who had capital, like Tata's, so they did spend money on developing Tata Motors and Tata Steel. Birla spent on few companies in cement and steel, Dalmia's earlier, so on. So those who had a lot of capital did go into somewhere to take risk. But imagine what happened. In this process, we were still quite open country. But from the US and Europe, we will not get the technology. Their companies were here and they were in consumer products. Hindustan Lever, very large company, is part of the Unilever, more than 10,000 crore sales. ITC, UK, again, in cigarettes and now consumer products, hotels also. So you can't see a large or well-established company like Siemens or General Electric or Raytheon setting up manufacturing facilities in India. So the technology did not come from high-tech sectors, and it did not come from any sector, though from USSR, India got what is called heavy industry. Bharat Heavy Electricals, Hindustan Aeronautics Limited, NTPC, BEML for earth movers, and so on. All these factories were set up by the Soviet Union without taking any share. So the heavy industry, heavy engineering industry did develop like that. But then, after developing these, they went back to their own places and all that. Much innovation did not take place. Now let's say, what were the next aspects of the policy? The space was new, so a separate organization was set up, Indian Space Research Organization. Atomic energy was new, so a separate atomic energy commission was set up. These were a little away from the government system. They had secretaries and directly reporting to or they had chairmen who were equivalent to secretaries to the government and directly reporting to the Prime Minister. So this system, part of the system got delinked and developed on its own. Didn't have any competition internally, but because the people were motivated, the people were good, both of them developed. We developed our own atomic energy, atomic bomb, which US tried very hard that we don't develop. No uranium will be available from them in France, etc., etc. And France gets it from Niger, but the USSR provided that. So at that time, these were secret agreements. Now we come to some specific technical development organizations. IARI, Indian Agriculture Research Institute. Indian Agriculture Research Institute, along with the agricultural universities, did a very good job and were responsible for the new so-called Mexican varieties, hybrid varieties of wheat. And those varieties of wheat is what got India out of the hunger status and become exporter even. Same thing about development of rice. Today in the Karnal belt they have rice, which is basmati rice, which is cholesterol free or low cholesterol. So these kinds of developments have taken place, which are on world scale actually. Recently, nano urea, fertilizers which are very effective for use. So like if that we keep on counting, patents were not made, but developments were there. And just like the land grant universities in USA, they had very strong extension departments. So seed varieties, for example. And in Punjab, people would jump the walls to just pick up some small quantity of new grain variety which is developed. And so much was therefore the interest, and the innovation spread very fast. So that is important. And therefore Punjab agriculture, Western UP agriculture, Haryana agriculture really became more efficient. Here one should remember that definitions sometimes given by the media and the West, even universities or think tanks, are something which shows to their interest. They still say that our farm productivity is less, because they compare crop to crop, wheat to wheat, how much is grown there in Canada, how much is grown there in parts of USA or Australia or Russia or Ukraine. But they forget that our farmers get 3 crops a year. Sometimes even you can call 3.5 crops a year, while they get only 1 crop a year. So look at the productivity of land. So besides this, what have they grown? Okay, since we're talking about agriculture, let's go to the next step. We became surplus in rice, we became surplus in wheat, and then the issue of pulses was there. That had not developed much because they were lower price. Prices kept on increasing, and now the pulses have become 10 times more production than what they were 10 years ago. In other words, come to it, then they will develop. Now, just about 2000, some things changed. There is this business of 2000 and zeros, and it has to be changed in all the computers, programming and all that, good old hand programming. And so Y2K it was called, Y2K issue. And now that business starts coming to India, because by that time programmers are available, because there has been a lot of unemployment and slowly people are moving in that direction. Before that, the hardware computer industry did not develop though. They were only components were brought in and they were assembled. And till today, really laptops, desktops, um, um, the software, etc., which makes our mobiles run almost like a computer, none of that is made in India. None of that is made in India. Now, sometimes one wonders why hardware did not develop at all. Such a large market. Even now, laptops, you stop imports for one day and then you open up the next day. All the laptops from China land up here. And we don't have our own laptops. Some local branding is there. However, in the ITES, the circumstances got so together that every bank, every insurance company, every large company, every company actually had to correct this in their programming about zero zeros, going from 19 something to 2000 something, okay, which earlier was not programmed. It was everything was 19. For example, these days we don't bother. We just write 2000 something something, not realizing that after 70 years or 80 years, there will be 2100. Now, so those banks gave the task of Y2K to Indian companies after competition and all that. Government gave a lot of incentive to make them as part of the SAZ, and therefore much capital was not required for it. So some companies which started the job earlier became stronger, like Infosys, HCL, Wipro, Tatas, right? And they started getting bigger and bigger and bigger and bigger kind of processing assignments. One thing has to be noted though. Hardly you can cite any one of these 4 big companies or 5 big companies or 6 big companies in the information technology enabled services. They have now billions of dollars of sales. But can you identify anybody any company which has made indigenous software, which is used in India or abroad? No. So therefore, you are taking the software for processing also from outside. Design is theirs. You do all the inputting work here or calling work here, call center, and have no control over marketing of it. In other words, it is like a textile mill where design is done outside. Some products come, you make, you spin, you make, they design, they market. Therefore, value addition goes somewhere else. However, the industry employs now more than 1 million professionals. It is good. Their salaries are better than the others. So, a self-sustaining system has developed. And if one client goes away, maybe the other one comes, because all of them need processing. And in all their countries, West, USA, Europe, UK, they will not be able to do that at that particular cost. Just not possible. Nor do they have so many people anymore. And digitization has taken place. So this is another element we will pick up, that how around that time, if you see, the digitization starts. And which towards the end, when we come here, talking yesterday in the parliament, finance minister, day before, saying that digitization has spread so much that there are 635 crore transactions every day. And so many people get their direct benefit transfers, etc., etc. So this traveled and digitization impact became greater and greater, and we are with the rest of the world as far as therefore digitization is concerned and fintech is concerned.